I'm going to share a screen. Okay, so today we're going to start the first part of chapter 7, which is arrays, and then we're going to move on to array list. Java likes this array list, is using it a lot of places. So I would suggest you spend some time to really understand the array list. You're coming in from C++, something to think about like your vector or similar to that for array list that, read it, practice it. You're going to see this a lot coming up. So we're going to talk about array, and then we're going to talk about array list, and then we're going to see the difference between those two, and when do we want to use what. I'm not going to go to the details of what arrays are. I'm expecting that most of you should know that if you pass the CS2. So how do we do it? Remember that Java is an object-oriented language. So majority of the things that we do in Java are creating objects. So arrays are one of those things. So arrays are also classes. So we have to create an object to use them. So the way that we're going to be creating an object is to use the word new. So if I have a class, I'm going to create an object for it. So if I just do this one, that is going to give me a null pointer from C++ or an address. So I have a variable, but it does not contain any addresses. Remember, in Java, because we have objects, I have to set some kind of alarm for 11 o'clock. Alarm. I'm sorry about that. I just want to be sure that I will be available for you guys at 11 o'clock. Okay, so if I'm talking and I'm not stopping about 10:50, 10:55, let me know so we can get ready for the test. Back to what we're talking about is when I declare a variable for arrays, we're going to be using this. So we're going to have a data type, bracket, and then we're going to have the name for it. This name is not going to do anything for me till I use the word new to create a new object. So now this array exists in the memory. So instantiation of an class is going to be an object, and that object is the one that we can use. So if I have a blueprint of a house, I have to build the house before I use it. If I have a direction of how to build a desk from IKEA, I cannot use the desk till I build it. So by just having a class, I cannot use it. And most of the things we're using in Java are going to be objects. So we got to create an object before we use it. Now, we can initialize our arrays to put some things in it. So in this case, it's going to pick up 1, 2, 3, 4, 5, 6, and it's going to put 6 elements in there. It's going to make the size 6. So at the same time, that's going to set the size to 6. It's going to put the elements in. Java is trying to be very helpful. So when you're creating new arrays, it's going to initialize it for you. So you don't have to worry about it. In C++, you have to worry about it. Of course, the latest version of C++ is trying to catch up with that. But in Java, if you create 10 element of double or int, is going to put the zeros in there. And if you do it a string, it's going to put nulls in there. So it's going to be already initialized. So, I'm sorry, we have more stuff over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can only use the braces when I am building my object. I cannot do that later after I build an object. So while I'm building my object, I can put initial value in it. I cannot use these braces after I build my, remember, constructor is going to happen only while I'm building my object. So I, just like your C++, if I go to the index 4, that would be my 5th element. I can put something in it or I can read from it. Just like C++, we are starting with index 0, and we can treat each element of our array with its index. So if I just call double value, it's going to create an array variable, but it doesn't contain any address in it. When I say new double 10, it's going to create me these things in the memory. So it's going to create this object. This new is going to create an object of double with 10 element. It's going to return its address wherever it is in the memory. Remember, every time you run the program, it's going to be in different location in the memory. It's going to return that address. And I'm going to take that address, I'm going to put it inside the variable that I have for my array variable. So the address of this is going to be here. And of course, it's going to set them all to 0. And if I go to element 4, that's going to be 1, 2, 3, 4, 5th element, index 4, and it's going to put something in there, whatever you are trying to do. Any questions so far? So that's the format that we're going to be doing. The first element is 0. The last element is the size of my array minus 1, just like your C++. In C++, if you would have gone outside of your size, it wouldn't say anything. It would just go and do it. In here, it's going to raise an exception. We will learn how to handle exceptions. But because we are not handling the exceptions right now, it is going to crash my program. So it's just going to create. So if I have 10 elements, I have 0 to 9. And if I try to access index 10, that does not exist. So we have something called the lengths. This is not a method. This is the instance variable, but it's public. So we can access it directly. So it's one of those cases that you have an instance variable as a public. So you can use the .lengths to get the lengths of your array. So what's the length of this array?
It'd be 9.
Length of the array is
10.
10. The last index is 9, but the size of your array, the length of your array is 10. And that's where we're putting it over here. So a good way, remember we talked about this before, that when you have hard-coded numbers in your program, you make them as a constant. We're going to call them final in Java. So we are going to be creating a final to put the lengths in there. And then we're going to use the lengths, or whatever you want to call it, for our array. So it's good to have some meaningful name, like array size, or if it's a student list size, maximum number of students, or whatever. It's going to make more sense than just the length. And then we can, in Java, read the lengths before we create our array. The newest version of C++, you can do it. Older version, you could not do it. So here you can get the lengths and then create your array. You don't have to have the lengths beforehand. But when you're creating your array, it's going to go in the memory and it's going to get that much stuff in the memory. So it's going to be fixed after you do it. So if my size of array is 10, It's going to go in the memory and it's going to reserve that much room and it's going to return its address. I can read the variable beforehand, before I create it. So it's happening at the runtime. That's generally what happens with the objects. What is wrong with this?
The type is different. It's double.
They have a different type. So if I am creating a variable for array of double, I have to have a double for the object, because that's the way I know where to go from one place to the other one. Remember, the data type for the concern over here is how do I go from the first element to the next one? In the memory, we are using bytes. So what's the size of, how many bytes do I need for my first element? How do I go to the second one? Is I get the size, multiply by, I get the, how many bytes do I need? And then I add it to my address. The beginning address is going to be 0. So I multiply 0 by, let's say, 4 byte, and then I add it with my original. Next one is going to be 1 times 4, 2 times 4, and so on. That's the way we're going to go traverse through the arrays. We don't really need the detail of it, but that's what's happening. That's why they have to match. Any other questions about what we have over here? All right, remember what we said, and we're going to repeat this, and you're going to be watching it. So what happens when I do this? I create an array. I'm going to call it the score. We can put the braces on there. What's the size of a score?
5.
1, 2, 3, 4, 5. So if I say the score dot length is going to give me 5. Now, what's going to happen if I create another one and I put equal to score? It's going to be pointing to the same location. This is generally not what we want. So when you are working with objects and you assign one to the other one, remember, each variable is going to contain the address, not the actual values of your object. So these scores is going to have the address of this object in the memory. Let's say I'm going to call it 1 million. So when I create the score, it's going to go in the memory in the location 1 million. It's going to create an object for me. It's going to return 1 million, which is the address of that object in the memory, and put it in there. So when I assign it, that 1 million is going to go to the second one. So the second one and the first one are going to have the same address, meaning they're pointing to the same location. So any modification to one of them is going to be to the other one. This is not generally what we want. Generally, this is not what we want. All right, so how do we go through the array? First of all, we can pass it as a parameter to a method. So in C++, when we were doing the CS2, you had to always pass the size of your array. Here, you don't need to, because you have that variable length that's going to give you the size. We will use the length for our loop. So in case we go back and we change the length of this automatically is going to change. We can change things, and we're going to see how we're going to do it. So Java has a system called garbage collector, same thing as Python. So it has a system in the background that's going to go around And if it sees the object that they don't have anything connected to it, it will remove them. That's one of the things that I really liked about Java, that we had to keep our eyes open for C++. In Java, is going to do it. So if you are coming from 3A or 8, you know that if you're creating any dynamic allocated memory objects, you have to remove it after you're done with it. But here, when you go out of a scope, meaning that your variable is not pointing to your array anymore, that array is going to be cleaned up later. You don't have to worry about it. It's going to happen. It might not make too much sense for CS2 students, but we talk a little more about it as we go along. So we do use a length because whatever length is going to come in, I don't have to worry about it. Remember, if I put a number here and the size would change, then I have to go and change it. This is one of the reasons that we don't want to use numbers. So let's say if I say int I 0, I less than 10, I plus plus, and then the size from 10 goes to 20, I have to go through all my program everywhere and find that 20, 10 and change it to 20. And I have to be sure that's what I want to do, because I can have 10 for something else. So we're just going to use the lot length, so we don't have to worry about those things. You can return arrays in Java. You could not do that in C++. Here you can return array. Remember, it is an object, so technically you're just returning the address of it. So I can put the data type here. The brackets is going to say that this can be array, and this method is going to return an array, something you didn't have in C++. So we can return an array. Remember that we are going to come up with the size of an array, and we're going to allocate that much space in the memory. But sometimes we are not going to fill up the whole array. So I started with 30, let's say 30 students in the class, and some people dropped the class already. So my number of students are dropping. So if I created an array of size 30 and I have 25, 24 students right now, I don't need to go through the whole array of 30 all the time. I just need to go to the numbers that I'm using. So that's when the partially filled array is going to come to play. So if I want to create an array for my students, I say, okay, the top level is 30, maybe I can go to 35, 36. I'm just going to go a little more. I'm going to set it to 50, or in this case, they set it to 100. But definitely, I'm not going to use all of them. So we're going to create a variable, again, similar to your C++. So we're going to create a variable. We can call it whatever we want to call it. We can call it current size or something similar to that. And then we're going to be using this one instead of the length. So if I have my array of 100 and I'm using only 20 of it, my current size would be 20. So for example, here I am reading from the keyboard. I'm going to put it in an array. So first of all, I'm going to check to be sure I have the double before I do anything in it. I cannot put a different data type into my array. So I'm going to be checking to see if I has next. Next thing I want to do is I want to be sure that I am not running out of space in my array. So my current size is going to start with 0. I don't have anything in there. And as I add more stuff to it, I'm going to add more on my current size. And I am not going to go beyond the length of my array. So if I have 100 elements and my current size becomes 100, I'm going to stop. I cannot have anything beyond that. So that's where we're going to be using the partial site. Remember this, go over this, be sure you understand it. So some picture for it. So from that point on, instead of the lengths, we're going to be using the current size. So if I have only 25 students, I'm not going to go and print all 45. I'm just going to print 25 students in my class. Okay, so we know that when we're creating an array, your array can have only one data type. Then you're going to have some issues that if I'm working with a student record, I have a student name and a student last name, which is a string, and then I have a student grade, which is a number, and then I cannot mix them up. So traditionally, what we were doing is we were having parallel arrays. One would keep the name, one would keep the grade, and that way we could keep track of it. And that's what we were doing initially. So now what we're doing, or if this one is int, or the other one is double, you cannot put them together in one place. Yeah, you can think about, I'm going to change all the int to double. That's not the efficient way of doing it, and that's not the correct way of doing it. So how do we fix this problem? Any suggestions? How do we fix this problem?
Create a new object.
We create a new object that's going to have these things as a instance variable. So in this case, I have account number and a balance. We're going to create an object of account that will have account number and balance in it. I don't care about the methods in here right now. All I care is I need those instance variables that they can be different. We did this in C through records because what is that? The structure in C++, struct, because we didn't care about the methods. So in C, we did not have classes. We did not have methods in a struct. So the difference between a struct and classes in C++, the starting point was a struct would not have any methods or functions. So that's one way of doing it, to take care of that. And then, okay, so we would go to every one of them and we would use so we could define these things as public, so we can directly connect to them if that's what we want to do. Otherwise, we have to have some methods to get these things. So I would go to accounts I dot account number dot balance, but I have to define these things as public. Otherwise, I couldn't be directly connected. All right, next step is enhanced for loop. Again, C++ has picked this up. So the newest C++ version, you would have this. You did not have it in the older version. So we have enhanced for loop, which is a shortcut for a for loop. What we can do is, instead of having something like this one that we had traditionally, we still can use that, is a shorthand for it. So we're going to introduce a variable.
So it's more condensed, right?
Right. So we're going to introduce a variable, and then we're going to put a colon, and we're going to put the name of the array. So basically, every time I go around, what's going to do is going to take the next element in the array, and it's going to put it in the variable, whatever we call it. So it's going to go through array, it's going to pick up each element, and it's going to put it in this variable. Now, because it's taking it from the array and put it in this variable, I cannot modify my array that way. Remember, it's going to take the variable, it's going to take the value, it's going to, so I'm starting with first one, that would be my index 0. It's going to grab whatever is index 0 is going to put it in this element. So inside of this loop, I'm working with a variable which is outside of the array. It is not part of the array. I get the value, I put it in this. So this is a very good way of doing some calculation with my array. But if I want to modify my array, remember inside here, I'm working with an element which is not my array. So even if I change the element inside this for loop, it will not affect my array. So this is mainly for reading. And if I want to modify or write, I'm going to be using this one. Just keep that in mind. So that's the enhanced one. What else did we want to talk about? Yeah, so we cannot update or stuff through that. I'm not going to go through this. So I'm going to quickly go over this. You should know these things. If you don't know it, go and read it. So we can do the sum or the average through the arrays. So we're going to go through every element. We're going to add them up together. So this is going to go through all the elements of my array. If I have partially filled array, I cannot use this one because it just goes through the whole array. To do the average, we're going to check the length to be sure that my length is higher than 0. That way I wouldn't have the division by 0. So this is something that we have to think when we are doing the design. So my average would be total divided by values.length. Again, we are using the lengths instead of the hard-coded numbers, but there is a possibility that my array is empty. So if my array size is 0, I'm dividing by 0. So I'm going to be checking, I'm going to put one extra check, be sure the size is not 0 before I do this. What's going to happen if the size is 0 over here?
Get out of, is it error out of bounds or something like that?
So I'm going to get the element. It's going to go through the values, which doesn't have any size. So it's basically not going to do anything. So my total is going to be 0. Sorry, I am rushing it a little bit because of the test that we are having. So for the maximum, I'm going to set the first one to my maximum, or if I want to do it minimum, and then I go through the elements after that one. And then if my element is higher than my maximum, I'm going to set my maximum to that element. I can use the same concept with my minimum. Chat. What do I have in chat? We can watch a recording. Yeah. Yeah, good. Thank you. So some of the things that you want to think about, if I'm displaying my array in certain way, if I'm putting a straight line, then the straight line, I can think about it that, is it coming after my first one, or it's going to come before the second one? But the idea is, if I have 3 elements, I only have 2 separators. So somewhere, somehow I have to account for that. I can check it to say if it's greater than 0, I'm going to do this. Or if I check it, if it's 0, I'm going to do this one. That way we don't print all of them. So if I want to look for things in there, you should know about it already. I'm not going to go through that. Linear search, removing an element. So remember, we have arrays. It's fixed, and that's where we're going to be enjoying the array list. So if I move something from my array, I have to move everything up to that position. So if I am removing this element, that means I have to, we can do it 2 ways. One, if my array is sorted. 2, if my array is not sorted. If my array is sorted, I have to move every element up. If my array is not sorted, I'm just going to go grab the last one, move it to this position, and I'm going to change my current size. So my current size, I have 25 students, and student number 10 is going to drop. So I just move my student number 25 to 10, and then I change the size from 25 to 24. But if they were sorted, then I had to move up. So that's one thing that we got to do. Same thing goes with insertion. If I want to insert something to array, if it's not sorted, I'm going to add it to the last element, and I'm going to change my current size +1. Of course, I have to check to be sure I'm not going outside of the limit that I have. So if I have 10, if my current size is equal to the length of my array, I cannot add any more. And that's what we're going to figure out how to do it. Okay, what else? So if we have a ordered array, if my array is sorted, we got to move things around. So that's one of the things that we're going to have with array, that if we're doing a lot of deleting and insertion, especially if it's sorted, it's going to take a lot of work. So that's what we got to understand, and that's what we got to know. That doesn't give us a permission not to use the array at all. Array has its place, and we're going to talk about that on Friday. So when we're going to use arrays, when we're going to use the array list. It's more efficient than array list because it's not, when it's got the size, it doesn't have to do anything. But we as a programmers got to do these kind of things. So if it's an array list, it's going to do these things for us behind the scene, but that means it's going to have overhead. So we're going to talk about those things on Friday. Well, same thing with the insertion. If I have room, I'm going to insert it. If I don't have room, then I got to do something about it. So we have to check it to be sure that my current size is less than my length before I add one element. If it's not, I cannot add any more element. If it's sorted, I have to push everything back till I have a room here to put it there. If I want to swap, I have to put it in the temporary one and swap it. You guys know about this already. So I'm going to put one of them in a temp, put the other one in there. All right. So remember what we said earlier. If we assign an array to another array, it's going to copy the address of the location of my object in the memory. So they're both going to be pointing to the same location. Most of the time, this is not what we want. Of course, if you are returning something from a method, or you're passing it through a parameter, we're going to be using this. We're going to be using the alias. So I'm going to be working in a method. I'm going to return an address of the object that I have in a method. You're going to grab that address. You're going to put it in your variable. Now the method that I have inside the array that I had inside the method is going to go out of scope. So the Java is going to go and clean that up. Till Java is going to clean it, we're going to have both of them pointing to the same location. Those are the things that are happening. I don't have to worry about it. I'm not too conscious about it. But generally, when I want to assign an array to another array, I want to copy the content of it. Now, when we are copying the content,
Do we use cloning? Is that when we use cloning?
that's what the copy of is.
All right.
So what we're going to do, we're going to take this array, we're going to grab this many elements of this array, and we're going to put it into this array. So remember about the initialization you had. If I put 10 elements into a new object of an array, it would create 10 elements for it. So how many elements I'm going to get here, That's going to be my size for this one. So in this case, I'm going to be putting it exactly the same size that I have here. So it is 1, 2, 3, 4, 5, 6. So I am creating these prices same size as this one. So it's going to have 6 elements. I could create it with less. I can create it with more. So if I have 6 elements of the values, I can put 3 over here to copy the first 3. I can put 15 in there. So it would copy the 6, but it's going to give me more room for additional 9 elements. So again, because this is a class, we have a method. That's the whole idea of the object-oriented programming, that you are going to be doing reusable code. So somebody has done it, I don't have to do it anymore. So I am going to be reading stuff from the user. I'm going to be reading stuff from the user, and then I get to the point that, wait a minute, I don't have enough room for my array. So I have created a student list of 30. I am reading the students coming into my class, and I run out of the space. So what do? I stop. I make another array of bigger size that I have. I copy the stuff that I have in this array to the new one, and then I can add more stuff to it. So you start reading from the user. As soon as you run out of a space in your array, then you make a new array with a bigger size, and then you add the rest of them in there. Again, your array list here, and the vector in your C++ does these things behind the scene. But here, you got to do it manually because it's reserved. So in this case, we say, you know what? We want to make it in double size. So whatever size I had, I want to multiply it by 2. So I am going to have a new one. So we're going to create a new one of double of the size of this one. And then we are going to copy the stuff over. So in this case, we're going to be using 2 times the value of the length. So it's going to grab the whatever it was on the other one plus additional elements. Does that make sense? So I am checking the length. If my current size is going to be greater than or equal of my length that I am reading, then I'm stop. I'm going to make double size of my array. I copy the stuff in the new one, and then I move on. Remember, this next one, in this case, I am creating a new array. I copy the old one into the new one. In this case, I have both of them with the same name. So I am grabbing the inputs and putting it in the inputs. If I have a different name, which I shouldn't, it's okay, it's going to work too. So I copy the old one to the new one, and I put it into the same name. So we need to practice on this. I'm going to stop right